You might think it's standard practice in crime and intelligence to look for patterns in criminal behaviour, but the clearest patterns emerge only when you have masses of data and a good way to analyse it, whether that's policing a tough neighbourhood or investigating a vast terrorist network. This is where big data comes in, filtering out useful information from huge volumes of data, making connections between times and places where crimes happen, making links between people and events. And if crimes happen across national boundaries, that can mean disentangling complex networks of criminal activity.
There are some people you can find, and Osama bin Laden is this node here.
Terrorists leave data trails. Joe Parry sells software that helps to make sense of those. It's useful for multinational corporations too. If faced with fraud or industrial espionage, it can help them identify culprits within their own workforce by understanding how employees have been communicating with the outside world.
In this diagram we're showing here, you can see these kind of red fans around the edge of the diagram. Those are external email addresses that are being emailed from the internal nodes. The internal nodes are green. What we're going to do now is just drill inside, and you can see that there are some red nodes in the center of the network, and those could be particularly interesting because they're external nodes that are being emailed very, very frequently by internal people. Now that could be for legitimate reasons, but it could be for illegitimate reasons too.
Battlefield information collected from the soldiers and sensors at national, theater, and tactical levels is immediately exploited.
One of our biggest clients is the US Army, and the US Army have mountains of data, literally data underneath mountains. With that kind of data, there's new kinds of challenges. Networks get larger in particular, and larger networks are really hard to think about. In this network is a network of terrorists, and the people in the network are represented by flags, which is the country of origin of the person. But even with that information in the network, you really can't see the dynamics of that network, how it's held together. We're able to combine the people from a particular country into one node in the network, and then that allows you to understand the interplay, for example, with the strength of the connections between individual nations.
He couldn't tell us exactly how the US Army is using his software because it's secret, but the point is that intelligence officers in the field often need to grapple with massive data sets in real time. So visualising links between disparate information helps make sense of it. But that's all still just visualising. What if you could do something more? Closer to home, police forces in the UK have built up masses of crime data through years of police work. And now that computing power is getting cheaper, it's possible to look back at that data and analyse it to try to build a picture of a possible future and predict crimes that might happen before they take place. Just like other police forces, Kent Constabulary is having to cope with budget cuts. They need to make sure they're making the best use of officers' time. So they're trying a new preemptive approach. All the 999 calls for the whole of Kent come into this control room, and every crime or incident is fed into a predictive system, the idea being to build up a database of information so that the police can identify hotspots and make sure that officers are in the right place. The system combines historic crime figures with elements of psychology, such as the fact that burglars tend to focus on areas they know and target neighbouring houses after a burglary.
It's not simply looking back to see what would happen in the future. It has an element of human behaviour and risk in there that says, look, you know, this is an area where there is a high risk of crime taking place because of a number of factors and not simply what's happened before. This actually identifies very small areas, 500 square feet, where the risk is highest that crime is likely to take place. So what you can see here is the district of Dartford, and there are 20 boxes distributed across Dartford at the moment. We can select against different crime types. This isn't about driving around the box in a car, this is about getting out of the car, engaging with the public, being seen in that area. There's a lot of research that suggests, 15 minutes in one of these boxes will deter criminal activity for up to 2 hours.
It is very hard to, for us to predict where it's going to happen, and you have to trust the programme.
So does it work, and is it worth the money? In the US, police claim the system brought down burglary, battery and assault in some areas by up to 19%. Here in Kent, they already put a lot of effort into prevention, but still hope to cut crime by perhaps 3%, some 3,000 fewer crimes a year.
No problems? Is it your business?
No, everything is all right. If I patrol an area and nothing happens, does that mean I've been successful, or does that mean I've been unsuccessful? You know, and actually, I suppose Peel summed it up very nicely in one of his principles, which is the success of the police is the absence of crime, not the visible presence of the police dealing with it. So for us, it is about sort of being there. It's difficult to measure, and if you just go on pure statistics, each year we're measured against the number of crimes that we have, and we hope to bring crime down. I think we've got to hold our nerve and see how this works out in the longer term, and if we're successful, crime will have come down.
But could big data be used to do more than calculate the risk of single crimes? Could it be used to learn from what we know of crime in the past to simulate crimes of the future? Well, that's exactly what researchers here in London are doing, using what we already know about the spread of disease to create a model of the spread of a riot.
We've managed to simulate the London riots, where putting together that data, thinking about it theoretically, then thinking about it mathematically, we can kind of create a representation of, based on the behaviour of these individuals, where were things likely to kick off.
Riots are relatively rare in the UK, so having a model means the police can try out different strategies. This one is based on the Metropolitan Police's own data.
So we've created a simulated environment by drawing all that data together to then possibly even practice and rehearse these sort of things in the future, or in a real life scenario, think of taking these applications forward to think, right, when we have a riot going on, it's happening in this particular location. If we deploy some resources to this particular location, what sort of impact are we likely to see?
When you start to appreciate the power of this approach, you might wonder, why aren't the police using big data and analytical software like this more widely?
The police are fantastic in dealing with the here and now. They have such a wonderful can-do attitude that their focus is often towards tackling incidents as and when they happen. And I think that something that they've overlooked or not doing enough of is where there's an opportunity to draw from larger volumes of data, to unpick that data to understand patterns, and then use that to influence day-to-day operational strategies, but longer-term crime prevention initiatives as well.
But some think there's a fine line between better policing using data from past experience and bringing together separate data sets to draw conclusions that might be plain wrong.
Manchester Police linked up the number of people that they thought were a problem and could potentially be entering the city to riot with their number plate cameras, and by using the registration details of cars, were stopping people and turning them around on the motorway because they felt they might be entering Manchester to commit criminal offences as part of the riots. Now the worry is there that that could be someone's parents driving the car. Your data isn't linked to an individual, it's linked to a vehicle. Some of these people had never been convicted of criminal offences, and some of them may have had perfectly legitimate reasons to enter Manchester.
Greater Manchester Police told us that in these unique circumstances, they stopped vehicles linked to people with previous convictions following intelligence, and only as a temporary measure. They checked they had the right people before deciding to let them through or not, and were also working with communities. It's that last point that Nick Pickles thinks should be the lesson learned from the riots.
Crime data tells the police where crime is happening, and intelligence on the ground, community policing, will help them spot problems before they arise. What won't happen is suddenly by throwing a lot of data into a computer, and you'll suddenly realise that a gang problem is going to move 3 streets away. That information comes from the communities, not from technology. And I think it's very dangerous when the police see technology as a quick fix, when in reality it's the issue that the police do not have the relationships with individual communities.
The use of big data to tackle crime is in its infancy. Before we can really judge if it has the potential to be truly revolutionary and predict crime, the police and intelligence agencies will first have to embrace the idea that data crunching can do more than simply speed things up and save some money.